Let's go to the fourth challenge. The other challenge is about the validity of assessments. What do I mean by validity of assessments? Let me show you another recent publications. Again, in Nature Communication. It's another really interesting study that has been done with the same team, Russell Poldrack again, and a group of collaborators in Stanford. What they have done, they have been trying to have an understanding about what we name by self-regulation and the measurements that we have for self-regulation. So what they have done, they collected 22 self-reports that are related to some extent to self-regulation with 37 behavioral tasks. And then they extracted 129 task-related, what we call derived variables. I mean, the outcomes, whatever the scores that we can get from the task. They call them derived variables. And then 64 from surveys, I mean, the self-reports. So they ended up having, let's say, 129, 64, putting them together, something like 189 different measures. And then they recruited 500 subjects in a platform that we called Amazon Mechanical Turk. It's a kind of an online platform for assessments that we use. And 150 of those participants took retest as well. Okay. The idea was, okay, let's do whatever self-report assessments that we can do regarding self-control, whatever assessments that are available outside. And then doing the behavioral computerized tasks for self-control, whatever concepts related to self-control and self-regulation, okay? Putting them all together and assessing the subjects for all these measures. And then, meanwhile, assessing them for their real-life behavior in terms of, do they smoke? Do they control their weight? Do they control their emotions? Their real-life behaviors. Okay, so the self-report of their real-life behavior, and also the psychological measures that we have and behavioral tasks, to see which of these measurements are related to the real-life behavior and how they are doing crosstalks with each other. So, first of all, within those 64 survey measures, I mean, by survey I mean self-reports, they, as you can see here, they try to do a combination of factor analysis and hierarchical clusterings. As you can see here, these are 1, 2, 3, 4. That will be 64. So these are 64 columns, and each column would be for one single score from one of the self-reports that they had in the database. Some of these would be clusterized to each other regarding risk-taking. Some of them are related to eating. Some of them are related to... So they are being clusterized in different categories. So it's something like categorization of these questionnaires into major categories, okay? And they have done the same for task measures, and they define some specific, let's say, groups of variables. One variable would be mainly related to speed. The other was related to being cautious, and some other measures. I'm not going to discuss about the details about them. I have a specific kind of reason I'm giving you these technical details. First of all, what they realized was whatever self-reports assessments that they have and whatever task-related assessment that they have, task assessments were related to task. Self-reports were related to self-reports. And there was not really good connection between self-report and task. This is one of the major challenges that we have in the field of cognitive neuroscience, that data from one dimension is related to the data in that dimension, but the data is not related to the other dimension. So, for example, activation in amygdala is highly related to activation in dorsolateral prefrontal cortex. But it is really hard to find any self-report that would be meaningfully related to the activation to amygdala. There are publications that they showed that before, in terms of some of the activations in amygdala would be related to some self-reports. But in reality, when you do that in large databases, you try to replicate that, it's not always easy to replicate. So it is really hard to find a specific self-report that would be highly related to a specific activation in the brain. So from one dimension to the other dimension. Or let's say a specific computerized task that would have one specific measure in a computerized task that would be always correlated with a specific activation in the brain. So from one dimension to the other dimension, things are always really complex. For example, if we find something as a blood biomarker for neuroinflammation, finding a correlation between that and an activation in the brain is complex. So from one dimension to the other dimension, things are always complex to find. So as you can see here in this figure. What they found, first of all, they have reported the data in 3 modes. First of all, this is what we usually do in our studies, what we call in-sample prediction. In sample prediction, within the database that they had, they tried to see whether binge drinking would be predictable based on the self-report data that they have. And they showed that yes, something like 15% of the data, 15% of the, so 15% of the binge drinking behavior could be predicted in sample analysis based on the self-reports that people have filled before. Okay, this is what they found. Then when we go for drug use, it would be something like, let's say, 7%. For mental health, it would be something like 30%. Okay. They have done that with cross-validation as well. So cross-validation would be another kind of better quality analysis. And 90% shuffled prediction means that just randomizing the database together and do the analysis again. So it means that what would be if we randomly have a database, a simulated database that is totally random noise, then what would be the level of prediction? So I mean, this as you can see here, if everything would be random, something like 1% of the signal could be predicted. So this is the reference point, something like the reference would be this is the signal in the reference point. So what they can see, it is pretty much reasonable in terms of finding a self-report that would be predicting the risky behaviors, but self-reports of risky behaviors, okay? And they are different. And what do we mean by these figures above? I will show you what do we mean by them later on. But let me show you one example. For example, for obesity, as you can see here, they have been successful to predict something like 15% of the signal based on the self-reports that they had. But what was predicting obesity were questionnaires that are related to EC, and EC, they were questionnaires that were asking about eating control. So it's obvious that if you have a patient who is reporting not being able to control their eating behavior in the self-reports, they probably have obesity as well in the real life. So it is not a very exciting discovery because, yes, there is a self-report that is asking about eating disorder, eating behavior, and that the report to this self-report is related to real life experience of being obese or not. So, I mean, this makes sense. So it is something that is reasonable. And then in terms of the mental health, it was mainly was explained by the EMC group. EMC group is emotional control. So it is obvious as well. I mean, if you have questionnaire which is asking about how much control you have on your emotions, and you are saying that I do not have any control on my emotion, probably you are depressed or you have a mental health disorder as well in your real life. So it is not really strange to have a good prediction with these self-reports for these real-life behaviors. But let's go for the task, that the behavioral task that they had. For behavioral tasks, it was totally impossible to predict who is binging drinking, who is problematic drinker, who is using drugs, who has mental health, based on the behavioral tasks that they had. So all those famous behavioral tasks, things like Iowa gambling task, delayed discounting task, all those behavioral tasks that we are talking about, they have not been successful in predicting real-life behaviors, risky behaviors in their real life. So they have not been successful in something like a 500 healthy control. So we are not talking about clinical population. But the relationship between behavioral task and real life behavior is poor. Just going back to the issue that I told you before, there is a high correlation between self-reports. There is a high correlation between or within the behavioral task. There is a high correlation within the kind of real-life behavior. But finding a relationship between the behavioral task and the real-life behavior is really complex. So predicting how your patient is going to do something in the real life based on the task that we are doing in the laboratory is going to be complex. So this is another challenge that we are facing in good quality research projects. People have reported many studies before that there is a correlation, but in reality, when we do that in larger scale databases with higher quality, we cannot replicate them. We cannot replicate many of those findings right now in terms of how much the behavioral task would be able to predict the real life behavior. And that is a challenge. And among those factors that were pretty much successful in reporting, mainly smoking and income, were a behavioral paradigm that I really like, which we call discounting. If you remember, we discussed about delayed discounting paradigm, which is about, do you prefer to wait for, let's say, 1 week and receive $100, or you prefer to receive $40 right now? So do you wait for 1 week and receive $100, or you receive $40 in cash right now? So which one do you prefer? And how much kind of making a delay of 1 week would just discount the value of having $100? So that is what we call delayed discounting. And it seems that those who have higher discounting, so those who prefer to say, okay, please give me that $40 today, I'm not going to wait for 1 week to have $100. So those people who would be more towards having obesity problems and daily smoking issues and having lower income and life milestones in their life. So that is making sense to a good extent. So this is one of the behavioral paradigms I really like, and I think it's a reasonably good valid behavioral paradigm. That, I mean, there are lots of things that we can do that with that specific paradigm, but that is still problematic in terms of finding the good relationship between these dimensions. So that was the challenge that I discussed about. It is hard to find good relationship between data in different domains, from neuroimaging to behavior, from behavior to behavioral tasks, computerized behavioral tasks, to real life behavior. From real life behavior, it seems that real life behavior and self-reports are pretty much close to each other, so they might have a better relationship. And even in that dimension, the amount of signal that was explained or were explained by the self-report was something like 15% of the entire signal. So this is not something like 80% of the signal. It's just something like 15% of the signal at the end. So this is another challenge that we face with the field of cognitive neuroscience, and that is going to be a little bit problematic as well.